lovely students. Today we're going to be doing some examples from Chapter 9. So I thought I would just start by doing this first one. I'm a little worried about how long this one's going to be, so I want to make sure that I separate these out a little bit. So this will be our first of many examples from Chapter 9. So in example 1, we're going to look at your local newspaper polls a random sample of 330 voters, and you find 144 who will vote yes on the upcoming school budget. Create a confidence interval for the actual sentiment of all voters, and we're going to use 2 standard deviations. So I could have come up with a 95% confidence interval, but that would just be a rephrasing of the statement. And I want to find a proportion of all voters who will vote yes in the upcoming school election based on the random sample. So in our sample, we should start our solution by making a plan. So my plan is going to be, hey, I want to come up with the interval. I want a confidence interval for 95% of all voters. We're going to vote on this referendum. So I want to be reasonably confident in my results, so I'm going to construct the interval using plus or minus 2 standard deviations in our sample, in our proportion. So we're going to be using 95%. So the idea here is I'm focusing more on the concentration conditions and the interpretation for this example, and I'll focus more on calculation in the next one, so try to bear with me. So the first thing I want to do is I want to check my conditions. So if you remember, one of the first things I want to ask is my plausible independence condition. So it's probably reasonable to expect that, you know, if they're using good surveying techniques, then it's probable that they were looking at something independent. Just because voters usually are independent. You know, for a good sample, good survey, this is very... Oh, sorry about that. My pen is fighting me a little today. Oops. This is completely reasonable. Anyway, moving on. So the random sampling. Here's where you might be a little scared, just because it doesn't mention that they actually did a random sample. It was just a poll. So it's more than likely that this was probably not random. Oh no, wait, it says random sample right there. Oh, we're good. Yep. All right. Moving on to our 10% condition. Wherein you have to ask yourself, is it probable that there is that 300 is 10%? So this is asking yourself, is 330 more than the eligible voters in the population? So, you know, you want to ask yourself, no, is 330 greater than 10%? And this is to say, you know, is my sample larger? Is my population smaller than 3,300? Because if you're dealing with a small town, then yes, you've broken this condition. But if we're not dealing with a small town, this is likely not true. So as we move along, we're going to go on to our success-failure condition now. So I got to check that I have at least 10 successes and 10 failures. So I'm going to do n times p hat, which is going to be, oh, that's the number of successes. That's just 144. Oh, that was actually easier than doing that. And then my number of failures, which is n times pq, or sorry, n times q, which is just, you know, 144 subtracted from 330. Which would be 186, and since these are both greater than 10, we definitely have at least 10 successes and 10 failures, so this is large enough. All right, conditions are satisfied. This means I know I can use a normal model to, you know, proceed through this, and so I can go ahead and do my confidence interval. So now I'm going to construct my confidence interval. I like to abbreviate confidence interval with CI. So the first thing I'm going to do is I'm going to note my sample size. And I know my probability of success is 144 out of 330. And then, and this is, about 0.436. I'm rounding a little bit in this example more than I usually would have, but today, fun, it's Monday. And I'm going to find my standard error since that's all I've got to work with, which if you remember is the square root of p hat times q hat divided by n. So if you calculate that out, that's the square root of 0.436 times 0.564, all divided by 330. And if you calculate that out, you get approximately 0.02. Oh, that's not a 2, is it? Yay, reading. 27. And we can go ahead and use that to come up with our margin of error. Remember, your margin of error is just your z-score, whatever happens to be, times your standard error. Oops, I put my parenthesis in the wrong spot. So since I chose my z-score to be 2, this is going to be 2 times my standard error, which I just found to be 0.027. If you multiply those two together, you get about 0.054. And I'm saying about here because I know this value, the 0.027, is rounded. Alrighty, now we can construct our confidence interval. So I'm going to take 0.436, which was our p hat, and add and subtract from it this 0.054. I should have put a 0 here to make it clear where that decimal point was. So I'm going to both add and subtract that, and that'll give me my interval. So if you subtract that, you get a lower bound of about 0.382 and an upper bound of 0.490. Ooh, that 4 did not come out good. Okay, there we go. All right, so let's describe this now. So what we would report is that we are approximately 95% confident that between 38.3% and 49% of voters will vote yes on the upcoming budget, which isn't very good if you need a majority. So just so I write this down, we are 95% confident. I should type this. That between 38.3% and 49% of voters will vote yes on the upcoming budget. Oops. Sorry about my big sigh. Ooh, your English sticklers are going to like the fact that oh no, I don't want to leave tablet mode, that I misspelled upcoming, so I'll fix that for you, lovelies. And as soon as I figure out how to edit these videos well, I won't ever do that again. Okay, so that's our first confidence interval video. I hope you enjoyed it. It should be a fun time.